Hey guys, in class we've been playing a bunch of games where knowing the probability of something happening helps you win. And so we're going to start moving to this area where we're going to calculate the probabilities first and then play the game so that we can sort of enter into the games with some strategies. Now, these notes are about using the counting techniques that we talked about in 10.1a and b to find some probabilities. So for instance, if I wanted to find the probability of 3 tails, that means that I'm flipping 3 coins. So I have my first coin, I have my second coin, and I have my third coin. Or you could think of it as flipping the same coin 3 times. So first flip, second flip, third flip. And this first flip, I can either flip a head or a tails. And the same thing for the next one and the next one. So for each of these situations, there are 2 different possibilities, 2 different outcomes. Now, some different ways that you could write this out. You could think of it as you could write a heads, and a heads for your first 3 flips. And then heads, tails, tails. Or heads, heads, tails. Or heads, tails, heads. Tails, heads, tails. Let's see, I've got 1, 2, 3, 4, 5. I know I've got tails, tails, tails. I could have tails, tails, heads, or booger. Which one am I missing? Oh, I could have tails, heads, heads. There we go. Okay, so I could write out all the possibilities. Now, the trick about writing out all the possibilities, and I just caught myself in this same trick that I'm going to warn you about right now, is that it can be sort of hard to make sure that you have all the combinations. Now, I knew the answer to this was going to be 8 because I know 2 times 2 times 2 gives me 8. So I'm kind of like cheating a little bit. If you didn't know what the answer was, though, writing the letters out like this might be prone to making some mistakes. So another way you could think of it is a tree diagram. On your first flip, you could flip heads or tails. And then on your second flip, you could flip heads or tails, depending on what happened on your first flip. And then on each of those flips after, you could do heads or tails. So each sort of level of the tree diagram, like this represents your first flip, and then your second flip you could go heads, heads, or you could go heads, tails, or you could go tails, heads, tails, tails. So this is representing like 1 flip, 2 flips. And then your third flip is out here. You could have heads, 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 tails, heads, tails, heads. So the tree diagram does the same thing as this, but it does it in a way that makes it a little bit harder to get messed up. And then on tree diagrams, the way you count how many options you have is you count the branches on the outside. So notice I have 1, 2, 3, 4, 5, 6, 7, 8 branches total. And so that would mean that there's 8 combinations. Now here, finding the probability that all 3 of these are tails means I want to know the number of ways I can get 3 tails over the number total. So let's see, if I look at this, the only way I can get 3 tails is if I flip tails every time. So there's one way that I can get tails, tails, tails. So I'll write to get tails, tails, tails. And there are 8 possible combinations here. So my probability is 1 out of 8, or if I were to hit that on the calculator, I could say 1 divided by 8 and then multiply it by 100 to get the percentage. I could say 0.125, or I could say 12.5%. And any of these are equivalent, they all mean the same, so whichever one you like better pretty much works. Okay. Now, that's an example with coins. I can also show you guys an example with like rolling dice. So on the Khan Academy problems the other night, you were looking at the probability of rolling at least 1 3 when you're rolling 2 dice. Well, an easy way to take a look at this, if we wanted to figure it out and not have to do a million more problems like this in the Khan Academy, is to think about our rolls. So we have a 1, a 2, a 3, a 4, a 5, or a 6 on a dice. 1, 2, 3, 4, 5, 6. We know that the total number of combinations here from experience is going to be 36 combos, because we know we're going to have 36 slots in here. And for at least one of them to be a 3, well, I could have a 3 and a 1, or a 3 and a 2, a 3 and a 3, a 3 and a 4, a 3 and a 5, a 3 and a 6. Or I could roll a 1 and a 3, a 2 and a 3, a 3 and a 3, a 4 and a 3, a 5 and a 3, and a 6 and a 3. So these are all the rolls that have at least one 3 in them. One of the dice was rolled a 3. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice I didn't count this dice twice. I only counted it once. So if I were to count that again, here's my first one. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 dice that have at least one 3 out of 36 combos. So the probability of at least one 3 is 11 out of 36. That's the chance that you're going to get one 3 on the dice. And then last but not least, another type of probability problem that you might see is the probability of rolling at most a 4. So like this, let's say, is for 2 dice. On Khan Academy, I think it's a little more obvious if it's 1 dice or 2. But let's say for rolling 2 dice, and we're rolling at most a 4. Now this isn't at most 1 4, it's at most, I think this means a sum of 4. So what I want to know is that my sums are at most 4, so I want to know what sums are 4 or less, right? So in this situation, I'm going to make my table again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Make your dice table. And now since we're talking about sums, I'm going to fill in the sums. So 2, 3, 4, 5, 6, 7. Let's see, this is 3, 4, 5, 6, 7, 8. 4, 5, 6. Okay. And since I want to know which sums are at most 4 or 4 or less, I'm looking for these guys right here that are 4 or less than 4. And so since I have 1, 2, 3, 4, 5, 6, I know that the probability of getting at most a sum of 4 is 1, 2, 3, 4, 5, 6, 6 out of 36, which on Khan Academy they're going to want you to reduce to 1 over 6 because 6 goes into 36 6 times. All right, that's it for your notes tonight. If you haven't done this Khan Academy yet, it's the basic probability on Khan Academy, or I think actually it's called Probability Space on Khan Academy. Please go ahead and do that tonight. Thanks, guys.